Question 1. There are 60 students at a college. 20 students study both French and Spanish. So that's going to be in here. 13 study French but not Spanish. And a total of 43 students study Spanish. So we've got to complete the Venn diagram. Well, 13 and 23 and 20, then that's going to be 56, which would mean 4 outside of both French and Spanish included. Now we've got to write down the probability that this student studies neither French nor Spanish. Well, that's going to be this situation here. It's going to be 4 out of the 60, which you can cancel down to 1 in 15. Now I've gone through that question quite quickly, and there's a reason for that. It's on a higher paper. If you want to see a slower explanation, then just flip back to the foundation paper, because this question appears on that as well, and you can just see a bit of a more detailed explanation. Okay, let's move on. Question 2. We've got to describe the single transformation that maps triangle P onto triangle Q. Now, the proper way of doing this is to join a point on triangle Q to a point on triangle P that correspond. Draw the straight line and then find the perpendicular bisector. It's basically the halfway point which meets the line segment A dash at right angles. So for example, this locus of points on this line. So we know that it's on there somewhere. That's the centre of rotation, that is. And if you've got tracing paper, to be honest, it wouldn't take a little bit more than a bit of trial and improvement to work out where the centre of rotation is. As it turns out, it's at this point here. To reaffirm this idea, if we call this B, and then this point here, B dash, and we drew a line joining those points up, the perpendicular bisector again would go through these points. Now it happens to be where the perpendicular bisectors all meet together. Now we'll have a look at this last one here. Let's draw this in blue. So we've got our line here, and I've exaggerated it a little bit. I'm just going to try and get it to join up the points. There we go. Move that slightly. We know in advance that it's here, okay? But just to show you that if you did do the bisector, the perpendicular bisector, it would go through something like this. That's not a very good part there, that's a little bit better. And you can use a pair of compasses to do that. I don't know if you remember that you put the sharp point here, do an arc, and then the sharp point here, do an arc, and then correspond to these ones here and here, and where they cross over is you join them up and you get your perpendicular bisector. It's where all the bisectors meet, and they would go through this point 0, 1. So describe fully the single transformation that maps triangle P onto triangle Q is a rotation 90 degrees anti-clockwise about centre 0, -1. So like I said, if you've got tracing paper, I think visually most people's eyes would be around this area here, and you just try a few points. You might try this one, this one, this one, this one, and then hit on this one, and it would work. Okay, so like I said, always put your hand up and ask for tracing paper, which is allowed. Question 3. Jean records the maximum daily temperature each day for 10 days. She also records the number of children going to a paddling pool for each of these days. She draws this scatter graph for her information. Jean's information for one of these days is an outlier on the scatter graph. Give a possible reason for this. Well, this one's the outlier. It doesn't fit the data. And let's have a look at why that could be. Well, I've said perhaps it was bad weather outside, so the children wanted to stay indoors. There's many reasons that you could give. That's just one of them. Now we've got to look I believe, at what type of correlation does the scatter graph show? Well, I would try and draw a line of best fit for the information. So let's move that like so. And then we want roughly the same amount of crosses one side than the other. Not always the case, but you just get a general line of best fit. You've got some tolerance either way. I believe that this would be a simple state of saying it's a positive correlation. Let's see if there's any more to the question. Well, it then says, on the 11th day, the maximum daily temperature was 19 degrees centigrade. Write down an estimate for the number of children going to the paddling pool on the 11th day. Well, it says the 11th day because you're using the previous 10 days, because don't forget this is what this shows. Jean recorded the maximum daily temperature for each day for 10 days. So for the 11th day, let's have a look at what 19 would have given based on previous data. And we should draw a straight line. I don't have a ruler here, so I'm going to do it freehand. But you've got to use your line of best fit. And then we should be able to read along to here, which would be 15, 16, 17, 18, 19 children. So I've put that answer here. Then the last part says it would not be sensible to use the scatter graph to predict the number of children going to the paddling pool on a day when the maximum daily temperature was 13 degrees centigrade. Give a reason why. Well, I think that's to do with the fact that around 13 degrees centigrade there's no line of best fit here, so you'd be making assumptions based on no prior data at all. So I'll put that down in writing for you now and you can see what you think. So my explanation would be the data would be out of range. We would be extrapolating. Now, I said extra there, extrapolating. If you interpolate something, then it's like INTER. So an intercity train, for example, goes between towns. So inter is between. So if you were interpolating, you'd be looking at the actual line between the limits, the start and the end. But if you're extrapolating, it means you're looking outside the range of what you have. So you don't want to be extrapolating here in this instance, because I think if you carried on here, you'd end up getting a negative amount of children, which I guess is another thing you could say. Whether that would be acceptable or not, probably would be. Okay, so that's that question done. The diagram shows a shape, and we've got to work out the shaded part. Now it tells us that the perimeter is 28 metres. So that means if we start from A and go round all the way back to A again, that should make 28. So let's see what we've got. So we've got 4 here, plus, well, I'm not quite sure what that is, so let's break it down. We know that that's got to be 3, and this we can call an unknown. And so we've got 4 plus x plus 3, plus 4 and 2 more, plus 3, plus 2, plus, well, we called this part to here x, so we're going to call that x as well. And that's got to equal 28. So let's simplify that. So we've got 4, 8, 10, 16, 18 plus 2x equals 28. So we're going to take 18 from both sides, and that's going to leave us with 2x equals 10. So that means x is going to be 5 after we've divided both sides by 2. So we know that x equals 5. So that means we can find the area of the entire shape. So I'm going to split it up into 2 rectangles. So this one is going to be 4 times 5 because that's our value of x, which is going to be 20. And I'll put the units in afterwards. And then we're going to have this one, which is 3 times, well, this was 6. I didn't label it from the beginning, but it was 4 and 2. It was this bit. So we've got the area of the other rectangle is 3 times 6, which is 18. So the total area is going to be 38 metre squares. Now we want to look at the unshaded area, and that's this part here. So this is going to be 4 times x plus 3, so that's 4 times 8, halved, because it's the area of a triangle, which is base times height, divided by 2. And when I say height, it's important that this is the perpendicular height. So on the calculator or not, that's going to be 16 metre squares. We can call that 1 there. And then for this one, we'll call that 2. Well, we're going to have 3, or this one here, 3 times 6, halved, because it's a triangle as well, which is going to be 9 metres squared, which is going to give us 25 metres squared. So we can work out the shaded part now is going to be 38 minus 25, which is 13 metre squares. Question 5. Solve the simultaneous equations 4x plus y equals 10 and x minus 5y equals 13. Well, I'm going to try and get the coefficients of x the same in both, so I'm going to call this equation A and B, just so for the explanation. I'm going to times equation B by 4, and that's going to give me 4x minus 20y equals 52. I'll call that equation C. And then I can notice here that I've got a 4x here and a 4x here. So I'm going to do what I normally do with simultaneous equations, and that is times both sides of one of them by -1. And I think I'll choose the top one here. So I'm going to do A times -1. So it's going to become minus 4x minus y is minus 10, and call that equation D. And the nice thing about these two now is I can add C and D together, and I'm going to have no x's, minus 21y, because I'm just adding them. So I've got minus 20y and minus 1 more, which is minus 21 of them all together. Then I've got 52 and minus 10, which is gives me 42. Then I can divide both sides by 21. And if minus y is 2, that means y must be -2, or just times both sides by -1. So that was nice and easy. Y is -2. And I can sub that into equation A, I think. So we'll have 4x plus minus 2 equals 10. Or you can say 4x plus -2 is 10. It's probably better. And then if I'm adding a debt, well, if I'm giving somebody debt, I'm taking money from them, in essence. So I'd have 4x minus 2 is 10. Add 2 to both sides, that would be 4x equals 12. Divide both sides by 4, so x would be 3. So you can look at some other videos I done on simultaneous equations. I think it's in a playlist called Simultaneous Equations, and you can see plenty of practice in there. Or look at someone else's, like I've said before. But they're the answers, and in an exam it's probably worth checking them so you can put them back into the originals and they should work. We'll just do the top one. 4 times 3, because we had x is 3, is 12, plus y should be 10. Is that true? Well, yeah, we've got 12 minus 2 is 10, so the first one works. You can try the second one yourself. So, question 6. Complete the table of values for y is 3 divided by x. We can use our calculator. 3 divided by a half, that's 6. 3 divided by 1 is 3, and so on. And then 3 divided by the 3 here is 1. 3 divided by the 5 is the same as 6 divided by 10, so that's 0.6. And then 3 divided by 6 is back to 0.5 again. So you can notice this correlation here, inverse relationship between these values here. It's worth noting. Now, let's have a look at drawing the graph now. So be very careful. So we're going to plot the points now. So we've got 0.5 along, 6 up, 1, 3, 2, 1.5, 3, 1, 4, 0.75, 5, 0.6, so 1, 2, 3, 4, 5, 6, and 6, 0.5. And then I've explained this question on the foundation paper as well, so if you want it to go a little bit slower, you can have a look at that one. It's on the foundation paper as well. So let's join the points up, and I always go underneath the arc in this kind of movement. I'll just explain this from underneath. It's easier to plot, and it's easier to graph rather, so I'll do it in red. So let's start slowly through here. I can turn the page a little bit more to help me, and then carry on, and then a little bit more to get the last one nice. Okay, so not perfect, but that would do it in an exam. So like I said, some of these questions on the higher paper appear on the foundation, so I probably spent a little bit more time on the foundation, not much more, but if you want to look at the question again, feel free. Question 7. Gina finds out the price of a CD box set in 3 different countries. So we know that it's £98 in the UK. We've got our calculators, so we're okay to convert this into pounds here for the USA. So if we do, well, £1 is $1.43. So if we do 134.99 divided by 1.43, then it would cost £94, well, £94.40 to the nearest penny in the USA. So I'll just show you what I did there. I did 134.99 divided by 1.43, which is converting into pounds for the USA. And then lastly, we know, this is a bit more tricky, we know that €1 is 73p, and what we can do is times both sides by 139.99, and luckily we have our calculator here. Then we'll get 139.99 euros, and that will be the same as, well, 0.73 times 139.99, and we get £102.19 to the nearest penny. So that would be to the nearest penny in Germany. So Gina wants to pay the cheapest price for the box set. So from which country should Gina buy the box set? Well, it looks as though the front runner here in terms of being cheaper is the USA. So you would say USA is cheaper, and just put the price there in pounds conversion. And that should be the answer for this part, but then the second part goes on to say, why might your answer to part A not be the best country for Gina to buy the box set from? And I think I know what it's getting at here. USA might not be best, so might not be best. I'll say due, I'll spell that, well, I'll write that a bit better for you, due to postage costs, because it's coming from a very long distance, if she did live in the UK, that is, and therefore it would probably be way more than £94.40 and probably more than £98. Okay, so that would be my reason for part B. Question 8. Given that A to B is the ratio 8 to 5 and that B to C is 3 to 4, I've written that out for this reason because if we look at B here, then we can write the ratios underneath each other. And the nice thing is, if we look at the lowest common multiple of 3 and 5, it's 15. So we've almost got to times the top one by 3, and we'd get 24 to 15, and the bottom one by 5, and that would give us 15 to 20. So these then match, and then we'd get our answer, which is 24 to 15 to 20. If you don't like that way, then another way of looking at it is if you have 8 to 5 and we divided both sides, say, by 5, that would give us 8/5 to 1. And if we looked at the second ratio, which was 3 to 4, and we try and get the B part, so this was A to B, and this is B to C, if we try and get the B part to match the first ratio, i.e. make it 1, we'd have to divide both sides by 3, and that would give us 1 to 4/3. Now these parts match, so 8/5 to 1 to 4/3 would be a partial answer, but we want to give the ratio as a whole number because the 1 is the linking part of the ratio because they're both the same, they both represent B. So we'd have to times everything through by, well, you've got it, the lowest common multiple of 5 and 3 is 15, which would link in nicely to what we had before. Question 9. Write 3.6 times 10 to the power 4 as an ordinary number. So think of it like a telephone number. That would be 3.6 times 10 times 10, and we do that 4 times in a row. So that's worth 10,000, and 3.6 lots of 10,000 is clearly 36,000, and you can try that on your calculator and you get the same answer. So that's a good thing to try. Then we've got to work out the value of 2.8 times 10 to the minus 2 divided by, and it's got the brackets there to help us, so we're dividing all of the first part by all of the second part. And my advice here is to do each part at a time. So this is going to be 2.8 divided by 10 twice, because that's what 10 to the minus 2 means. That's really what it's saying. If it was a positive 2, then we'd be timesing 2.8 by 10 twice, but this time we're dividing it by 10 twice. So we can do that step on our calculator. 2.8 divided by 10, divided by 10 again, and that gives us 0.028. And then we've got to do the same here. So let's look at what this is telling us. It's saying 4.7 times 10 to the 5. So what we can do here is say that we've got 4.7 times by 10 5 times, and 10 to the power 5 is 100,000. So we have 470,000 here, and again you can do that on a calculator if you want. And so I'm going to divide 0.028 by 470,000, and I get 5.95744 and so on times 10 to the minus 8. And the reason that I didn't put all the places on my calculator is because it wants it to 3 significant figures. So I will go 1, 2, 3, cut off here, and this 7 will change the 5 to a 6. So I'm going to write 5.96 times 10 to the minus 8. Now, another way of doing this question is you can say to yourself, just write it straight out, so 2.8 times 10 to the minus 2 divided by 4.7 times 10 to the 5. This negative index here is the same as writing 2.8 divided by 4.7 times 10 to the 5 times 10 to the 2. Use the rules of indices here, and you'd have 2.8 divided by 4.7 times 10 to the 7. Now you can either do 2.8 divided by 4.7 times 10 to the 7, or you can do 2.8 divided by 4.7 and then times it by 10 to the minus 7. So what you could have done was bring this up to start with here and call it 10 to the minus 5. That's really up to you, whichever your preference is. So I'm going to just have a little go at this one and see what it does. So 2.8 divided by 4.7, and that gives me 0.5957446 and so on times 10 to the minus 7. Now be careful, because we've got to give standard form, which is a number between 1 and 10. So that's 5.957446 and so on times 10 to the minus 1. And the rules of indices would give us exactly the same. So if we cut it off here, we'd have 5.96 times 10 to the minus 8 to 3SF, and I probably should have said that here as well. Now the reason I've done that two different ways is because that's a good exam technique. Try and arrive at the same answer a completely different way, and then that should up your chances of knowing that you're correct. Okay, there's not just one way for a problem. That's the whole idea about maths. There's multi ways for the same answer. Question 10. The table shows pairs of values of x and y, and we've got to tick the correct statement below. Well, if y was proportional to x, then that means y would be equal to kx for some value of k, which incidentally means that if x was 0, y would be 0, no matter what k is. So this goes through the origin, as do all of these. Okay, they should all go through the origin. Now, that's an important feature, because if I was to do a little sketch here, and we're looking at the first one to see whether that fits. If x is 5, y is 400, so that means x has to be times by, well, you can use your calculator, and I can see that's 80. So that would be a relationship y equals 80x. And that would work, that would go through the origin. But what about this here? Is 6 times 80 576? Well, it isn't. So that would mean that there'll be a different constant, k, so it can't be relating to both coordinates. So it has to fit both of them, so I'm afraid this one is out. Another reason why it's out is if you plotted 1, 2, 3, 4, 5, 6, 7, 8, say, and 1, 2, 3, 4, 5 is here, and 6 is here. If you were to look at the y-axis and go up, say, 2, 4, 6, 8, up to 800, my scale's probably not brilliant there, but the point I'm trying to make is if you plotted these, so 5 along, 400 up, and then 6 along, 576. Then, as a sketch here, if you thought they were on the same straight line, this would not go through the origin. Okay, so that would rule that one out. Let's try this one next. So, if y was proportional to x cubed, then y would be equal to kx cubed for some value of k. Well, if we looked at x cubed, then if x was 5, x cubed would be 125, and use your calculator if you want. If x was 6, x cubed would be 216. Well, if you had to do 125s into 400, which I'm going to do now, that would give our value of k. So I'm going to do that now. 400 divided by 125, that would give me 3.2. So k would be 3.2. Now that has to be the same value that would have to work for this one. So is 3.2 times 216, let's check, is that 576? No, it gives 691.2. So this one is out. So this one is in, but let's have a little look at why it is. And we can answer part 2 at the same time. So if we said y was proportional to x squared, because we've got rid of the other two options, so by default it would be this one, that means y would be equal to kx squared for some value of k. So let's look at the x squared values. So I'll put the calculator down. So let's have a look at the x squared values. So when x was 5 and 6, x squared would be 25 and 36, but our y values are 400 and 576. So 400 divided by 24, well that's 16, and you can use your calculator if you want to verify that. And then luckily enough, 36 times 16, well you can use your calculator. I'll do that quickly actually. 36 times 16, and yes, you get 576. So we've worked out the formula then. Y is equal to 16x squared. Now that would go through the origin, and it would also go through these 2 points here. So if I enlarged this diagram, this may or may not work wonderfully, but I'll give it a try. So if I know it goes through the origin here, then it's got some kind of shape like so. Okay, so not a straight line, not a cubic, but a quadratic of the form y equals 16x squared. Question 11. The bottom of a ladder is on horizontal ground and the top of the ladder is leaning against a vertical wall. It says the bottom of the ladder is d meters from the wall and the top of the ladder is h meters above ground, and the angle is given as x degrees. Some safety instructions say it is safe to climb the ladder when h equals 4d. So we'll just make that the case. Now it says work out the value of x when h is 4d. Well, without explaining all the ins and outs of trigonometry, which again you can see on some of my trigonometry videos on the unit circle, we'll go straight into it. And we've got the angle here, so we've got the opposite and we've got the adjacent. So opposite over adjacent would give us tan. So we can write tan x equals opposite over adjacent. No matter what the value of d is here, the ratio would be 4. So tan x equals 4. So what we're trying to do is find the inverse operation. So we do tan minus 1 both sides, or you'll probably just press the tan minus 1 button straight away on your calculator. Make sure it's in degrees, and would have x is tan to the minus 1 of 4. Let's have a look what that will give. So inverse tan of 4, and that gives us in degrees, and all the calculator display gives me a 75.96375653, and we want, well, it doesn't tell us what to give it to, so I'd probably give it to, I'll probably say 1 decimal place or 2 significant figures. Either way, x is going to be 76 degrees, and I'd probably say to 2 significant figures here. The next part says, some different safety instructions say the angle between the ladder and the ground should be 75 degrees. But I guess if you got part 1 wrong, you might not know what this is actually getting at. So we've got something to go on here because we've got part 1 right. It says the ladder is moved so that x is 75 degrees, and it says how does this affect the height h meters of the top of the ladder above the ground? Well, I think that's a simple question there, because we worked it out to be 75.96 degrees, 2 decimal places. So surely if the angle is decreased here by nearly 1 degree, then to do that I'll exaggerate it here. The height's going to be less. So that's what my explanation is going to say. It's going to say that making the angle 75 degrees will decrease the value of h. Question 12. Here are the first 4 terms of a quadratic sequence. 3, 8, 15, 24, and so on. And we need to find an expression in terms of n for the nth term of this sequence. But we'll look at the first difference first. So it's 5, 7, 9. And then we'll look at the second difference. And the second difference is constant. So if the second difference is constant, then it's a quadratic. So we're going to have a little look at what the quadratic terms would be. So let's do the n squared sequence. So that would be 1, and then 2 times 2 is 4, 3 3s are 9, and 4 4s are 16, and so on. Now, one thing you might have been taught before, I'm not going to go into massive detail now, is that if you have your second difference and it's constant, you always halve this number here, and that will tell you how many of n squared you need. So 1n squared or n squared should be enough now to do a comparison. So what do we need now? Well, we'd need to add 2. Here we'd need to add 4. Here we'd need to add 6. And then, this is nice, we'd need to add 8. So we definitely know there's an n squared involved, because that's given us a situation now where we've got 2, 4, 6, 8 is all we need, and so on. So let's have a look at how those numbers change. Well, they all go up by the same amount, which means this is a linear situation. Now, 2, 4, 6, 8 is just the 2 times table, and that can be represented by the 1 times table, which is 1, 2, 3, 4, 5, doubled, so i.e. 2n. So what that means is that if we took 1 times the square numbers and added twice the 1 times table, then we should get the answer. Well, we can double check that just one more time. So is the 2 times table plus 1 of the 1 times the square numbers, so 2 and 1, yes, that's 3. 4 and 4, yes, that's 8. 6 and 9 is 15, and then 8 and 16 is 24. I'm sure there's plenty of ways of doing these type of questions, and there's some assumption that you know roughly what to do. If you're not sure, then look up finding terms of quadratic sequences or finding the nth term, and you'll find a lot of videos giving much longer explanations. But I'm sure as we go through many of these types of papers we'll come across this type of question again, that's for sure. It says the nth term of a different sequence is 2 to the power n plus 5. Now, if we have first term, second, third, fourth, and fifth, and so on, then if we wanted to look at 2 to the power n plus 5, well, when it's 1, and you can use calculator here if it starts getting difficult, 2 to the 1 is 2, plus 5 gives 7. 2 to the power 2, which is when n is 2, is 4, plus 5 is 9. If n is 3, here, then we'd have 2 to the power 3, which is 8, plus 5 is 13. And 4, 2 to the 4, 16 and 5 is 21. 2 to the 5 is 32 plus 5 is 37. Oh, and look what's happened here. 36 is not a term of this sequence because by the time we've done 37, we've gone past 36. Okay, so that's one way of looking at it. Another way of looking at it, which is a bit more complicated, because you have to understand that all the terms in this sequence will be nice whole numbers, because you're not going to get any fractional numbers for n, like half or 1.7. It's either 1 or it's 2 or it's 3 and so on, the integer values. And we sometimes call them here n, or the natural numbers, okay, so positive integers. So one way is to say, well, is 2 to the n plus 5 equal to 36? Does that give us any information here? Well, we can try and take 5 from both sides, and then we'd get 2 to the power of something is 31. Well, 2 to the power of n means that you're taking the number 2 and you're looking at it successively timesing by itself. So for example, 2 to the 0 is 1, 2 to the 1 is 2, 2 to the 2 is 4, 2 to the 3 is 8, and so on. So it's basically a doubling sequence. And you can just say here that 31 is odd and not a doubling number. So you could say that, and that would be good enough, I think, because 2 to the n would have to be, could be odd if n was 0, but again the sequences that you know will start from n is 1. I'd probably go with the top explanation, to be honest. But then you may just like this algebraic approach here just as much. You'll have your own kind of preference in terms of your number versus algebra skills. Okay, so let's have a look at the next question. Question 14. We're given that 3 to the power negative n equals 0.2, and we have to work out the value of 3 to the power 4 to the power n. This incidentally is the same as 3 to the 4n. You wouldn't necessarily say 3 to the n4, that's just not mathematically used at all. So you want to look at your rules of indices if you're not sure on that. So back to here, the first thing of interest is the negative sign here. So that would indicate a reciprocal, so we've got 1 over 3 to the power n, and I'm going to write the decimal 0.2 as a fraction. And that now helps me because my numerators match up, so my denominators here must be equivalent. So I'll have 3 to the power n equals 5. And that's really significant now, because I have to work out 3 to the power 4 to the n. Now, as 4 times n is the same as n times 4, that's the same as 3 to the n to the power 4. Now we know what 3 to the n is. We've indicated here that it's 5. So that means what we're looking for is 5 to the power 4, and on your calculator, or you can do 5 times 5 is 25, and then you've got 25 again, and of course you're going to get the answer of, and I'll just change the ink colour here, you're going to get 625. Question 15. We're given a shape here, a circle, and we're given a sector here, and we're given the triangle, we can see that, and we're given a segment here, a minor segment. Now we want to see what percentage the area shaded, i.e. that little segment here, is as part of the whole circle. So we can definitely find out the area of the circle to start with, and that is pi times the radius squared, which is 900 pi, and that will be centimetre squares. Now, I'm not sure how good you are at finding areas of sectors, but if you think about the whole sector here, the slice, then that will be 80 360ths, because 360 is the whole way round and we've just got 80 degrees out of that whole turn. So the area of that sector would be 80 360ths of the area of the entire circle, which is 900 pi centimetre squares. And you can do the rest with your calculator, it's up to you. So I'm going to cancel these and I'm going to have 8/36 of 900 pi. And then I'm going to divide this by 9 and this by 9, and then 4 into 8 is 2. So I'm left with 200 pi centimetre squares. Now, if you use the calculator and put pi in there, you'll be at a decimal at this point, and that's probably fine, but I'm just going to leave it all in terms of pi. So that's the area of my sector. Now I want to find the area of the segment here, this little part here. Well, if I do the area of this triangle here, taken away from the area of my sector, which I already have, then I'll be okay. Now the area of that triangle is a half times 30 times 30 times sine 80. So it's a half AB sine C. Okay, so that's the formula we use for that one. And I'm sure there's plenty of explanations on the internet involving the area of a triangle. Now, that would give us 900 over 2 sine 80. And that will be in centimetre squares also. So if I want the area of the segment now, that's going to be the area of the sector, which is 200 pi, minus, well, I'm going to cancel 900 over 2 to be 450 sine 80, and that's all in centimetres squares. And then what I want to know what fraction, what percentage of the area of the circle is shaded. So I really want to do the area of the segment divided by the area of the circle, and then times that by 100. Now I haven't used a calculator yet, and of course you can be doing that as we're doing the question. So I'm going to say 200 pi minus 450 sine 80 all over the area of the circle, which is 900 pi, and then times that by 100. So I'm going to divide top and bottom by 100, and that will give me 200 pi minus 450 sine 80 all over 9 pi. And then I'll probably use my calculator now. So I'm going to do the numerator first. So what do we have? 200 pi. Just got to find the pi button here. And I get 185.1550419. Very important to write down all of your calculator display. And then I'm going to divide that by 9 pi. But I'm going to put the 9 pi in a bracket, because if I don't and I divide it by 9 and then times by pi, that's like having the pi up here. And we don't want that. So we want to keep it all being divided by 9 pi. So 185 divided by bracket 9 pi. And that gives me 6.548520034. So if I want to give my percentage of the area of the circle that is shaded, then I guess the angle to begin with was 2 significant figures, the radius was 2 significant figures, so I'm probably going to give it as 6.5%, and I'm going to write 2SF just there, and that should be fine. So notice if you'd have decimalised from the beginning using the calculator, then that's absolutely fine. It's always good practice to do these without a calculator, because then on the non-calculator papers you'll just be so much better at your number methods. But then again, you know, that's completely up to you. Question 16. For her maths homework, Helen answered the following question. She shaded the region that is defined by the following inequalities: x plus y is less than or equal to 6, y is greater than or equal to 0, and y is less than or equal to x plus 2. Apparently she made 2 mistakes, and we've got to write down those 2 mistakes. So let's start having a look. Well, let's start with this one. Y is greater than or equal to 0. Well, y equals 0 is the x-axis, and x equals 0 is the y-axis. So is that shaded region above the x-axis, i.e. y is greater than 0? Yes, it is. That's fine. Now let's have a look at the next easiest one to do, and that is, let's have a look at the line y equals x plus 2. So its intercept should be at 2. It should have a positive gradient of 1 in 1. 1 in 1. That looks okay. And we've got to shade everything that's equal to that line and less than it. Well, there's one mistake, because the shaded region is above that line. So the first mistake is that she should have shaded underneath. So that's the first thing we can write here. Let's just go down to here. So should have shaded y is less than x plus 2, i.e. should have shaded below this line. And let's have a look if there's any other errors. So let's try and look at this one here. Now if x plus y is less than or equal to 6, then let's rearrange. That means y is less than or equal to minus x plus 6. So this has got to cut at 6, but it doesn't. So that's another error. We don't have to find any more. So the next thing we can say is the intercept for x plus y less than or equal to 6 is drawn incorrectly. Okay, so there's 2 mistakes, and let's move on. Question 17. Here is a speed time graph showing the speed in meters per second of an object t seconds after it started to move. We've got to use 3 strips of equal width to find an estimate for the area under the graph between t equals 1 and t equals 4. Well, let's change the ink on here so it's done properly. So we want between 1 and 4. Okay, so 3 equal strips. Well, we can see 3 equal strips here, and we're going to make trapezia out of this. So there's 1, there's 2, and there's 3. Now the nice thing about these trapezia is is that they all back onto each other. So we can find the height of this one, So it's 1, 2, 3. Now I've written over this a little bit here, so I'm going to just look at my original. And it looks as though it's roughly 3.6. The next one looks to be about 6.4. And then we've got, I think that's 8.4, and then 9.6. And the heights of them are all common. They're all 1. So the area of a trapezium is height over 2 lots of A plus B. Now, the nice thing about this, if we did it all in one go, we could start with the first one and say that's height, which is 1 over 2 lots of 3.6 plus 6.4, plus the next trapezium, which would be height over 2 lots of, well, 6.4 is common. It's a common height, so it was shared by the first trapezium and this one we're trying to do next, plus 8.4 plus a half of, well, 8.4 plus 9.6. So I hope you see why we can group all these together and do it all in one go, because a half is common, i.e. h over 2, and then we've got one of the first ones, two of those, so 2 of 6.4 plus 8.4 plus one of the last ones. So on our calculator we just need to do that, so let me try. And I get 21.4. So that would be the area that I would have here. Now we know that the units here were, speed was meters per second, okay, and time is in seconds obviously, so meters per second, so we want the area here is the distance travelled, so I would say 21.4 meters. That's what it represents. The area underneath is the total displacement. So I've written that there. The area is the total distance covered, and then it says explain whether your answer in part A gives an underestimate or an overestimate. Well, if you think about it, when we looked at these trapezia, can you see they were underneath the actual curve each time? So we would have done an underestimate. Okay, if it had been over, i.e. if the curve had been this kind of shape, then we may have had an overestimate, but we did an underestimate. Okay, so I should write that in here. So underestimate, and I'd probably say things like the chords, i.e. these bits, the chords are all under the curve, because we don't want to lose any marks. Okay, so that's as best I can do for that question. Question 18. Quite a difficult question for me. I may have got this one wrong, so I'm not sure exactly how to quantify what I think the answer is, and I'm welcome people to comment and say if they know a better way of doing it. I think if you have to choose the roles of head girl, so let's say that's HG, and then deputy head girl, and then head boy, and then deputy head boy, I think, say if you started with picking the first one, you'd have 95 choices because there's 95 girls, and then you'd only have 94 choices left for deputy, because for each of those second choices of deputy you'd have already made 95 choices for head girl. So there's definitely 95 times 94 ways of choosing head girl, deputy head girl in either order, because 95 times 94 is the same as 94 times 95. And what I mean by that is you could have chosen your deputy head girl first, and there's 95 ways of doing that. And then you could have said, right, I want the next one to be the head girl, and there'd only be 94 for that. So that's what I'm saying about those being the same answer. And of course, use your calculator to check it out. For head boy then, the same argument is here. So 87 times 86 and 86 times 87. Now the linking part, and this is where I get a bit stuck, but I think this is right, that if you did the girls first and then you sorted the boys out afterwards in terms of seeing who was going to be head or deputy, then if you did the girls in the first instance, then you'd have that 94 times 95 down first in terms of how many ways that is, and I'll just do that on the calculator. So that'd be 94 times 95, which is 8,930 ways. And then if you did the boys straight after having chosen the girls, you'd have 86 times 87, which is 7,482. Now, you could have chosen head boy first and then followed that by deputy girl and then followed that by deputy boy and then head girl. That would have still given the same answer as 8,930 times 7,482, which I get as 8,930 times 7,482, 668, 14260, which is 66,814,260 ways. So that kind of makes sense to me, and that's what I would do in the exam. And if you think differently, then please comment with what you think the answer is, because I don't always have these mark schemes at hand, and for this particular one I don't have it at hand, so I'm going with that. Question 19. Before I start this question, I want to just look at this formula here very quickly, because I get asked about it quite a lot. Well, that's the equation of a straight line, where x1 and y1 is the coordinate of a point which the line definitely goes through. So x1, y1 is a coordinate that the line definitely passes through, and m is the gradient. Okay, now I want to just show you where that comes from very quickly. So if you want to fast forward this bit, then be my guest if you already know it. So if I have x and y axes here, and I just put a point here and call it xy, and a point here calling x1, y1, join this up to here, then its gradient, I can use a little triangle underneath, and this distance here will be y minus y1, and this distance here will just be x, this x here, minus x1. Now, what's that got to do with this equation here? Well, to find the gradient, I always say if you travel 1 unit along, however high you go up or however low you go down, that number is the gradient. So I can divide every length of this triangle that I've created here by x minus x1, and I've got to do the same to this length here. Don't have to worry about the hypotenuse because that's not to do with the gradient right now. We're just looking at the change in y over the change in x, i.e. this length here as opposed to this length here. Now we've managed to get this number equal to 1, so what I have got is a movement from here to here of 1, so this number here must be my gradient. And if you look carefully at this, it gives you y minus y1 divided by x minus x1 equals m. And I think you can see that if you multiplied both sides of this by x minus x1, you just get the equation here of a straight line. And that's the one I'm going to use. So the rest should be plain sailing now, because it says that P has coordinates -9, 7, and Q has coordinates 11, 12. So I can join those up. And we have to find M, and basically P to M from M to Q is 2 to 3. So from P to Q there's 5 parts. So we've got to split that into fifths. That's the first thing that I would do. So I know that if I draw a triangle again here, I can say, well, from -9 to 11 on the x is a distance of 20, and from 7 here to 12 here on the y is going up by 5. So if I split that down into fifths, so if I divide the 20 by 5, I get 4 for each part, and if I divide the 5 by 5, I get 1 for each part. Now it says here that M would split the line PQ into a ratio 2 to 3. That 2 and 3 adding up to the 5 parts, which is the whole distance from P to Q. So from P to M, that's got to be 2 of those 5 parts, i.e. 2 fifths. Now we know then that to get from P to M, we've got to move 2 of these, which is 8 this way, and then 2 of these, which is 2 that way. Because don't forget, we worked out that 1/5 of the movement was 4 on the x and 1 on the y. So 2 fifths would be 8 and 2. So P started at -9, 7. So M must end at, well, we go up by 8 on the x, so we'll end up at -1. And then on the y, we'd go up by 2, which would leave us at 9. Now my formula comes into play, which is the best one by far to use. And I simply say here, right, okay, I write my formula down. So I now know a point that the line definitely goes through, because it says it's perpendicular to the line segment PQ and it passes through M. So I know that my x1, y1 is just my coordinate of M, which I now have. Now, it's unfortunate that the question's called it capital M, so I'll make it look like a capital. We don't want to confuse that with this M here, which means the gradient. Now, it says that the line is perpendicular to the line segment P to Q. Well, we can definitely find that gradient, can't we? In fact, we've really found it in its lowest terms, because if we say to ourselves, it went along 20 here and then 5 up, well, we could scale that down by 20 each way, and that would mean that for every 1 I went along, i.e. 20 out of 20, I'd go up by 5 and 20, which is a quarter. So that's one way of finding the gradient of PQ, and I write that as M of PQ is 1 over 4, or 1/4. Another way that people like is to say, use this one here and say the gradient is the difference in y divided by the difference in x. So if I look at the difference in y, don't forget there's 12 here and 7 here, so I'm going to do this number minus this one. I could do this one minus this one, but then if I do that, if I want the difference in x, if I started from left to right, I'd have to take away from left to right here. I can't swap the order in which I do it. So I'm going to do 12 take away 7 divided by 11 take away -9. So that gives me 5 over 20, because 11 take away -9 is 11 add 9, and that also gives me a quarter. So I'm sure you've got your own way of finding the gradient there. Now it says that L is perpendicular, so you should know that if M of PQ is a quarter, i.e. the gradient of PQ is a quarter, then the gradient of the line we want is going to be -4. Okay, because the gradient of a line times the gradient of a line that's perpendicular to it should always equal -1, and there's plenty of videos explaining that. So if we knew it was a quarter for one of them, then it must be -4 for the other, because only a quarter times -4 will give you -1. So we've got all the ingredients we need now. So we've got the gradient of the line is -4, and we also know a point that it goes through. So all I have to do is shove those numbers into this formula, and then that's the answer. So we'll have y minus 9 equals the gradient, which is -4, lots of x minus, and let's be careful here, x minus -1. And then I'd have y minus 9 is -4 lots of x plus 1, which gives y minus 9 is -4x minus 4. Add 9 to both sides, and that gives us y equals -4x plus 5. Now, you might not be a great fan of this formula, but when you come to do A-level, which a lot of you will do, you'll use that a great deal. I'm also fine with you using y equals mx plus c, and you can create simultaneous equations, i.e. finding the value of c once you know a value of x and y. That's also fine, but there's one explanation for you anyway. Question 20. Here is a sketch of part of the graph of y equals p times q to the x, where q is greater than 0. Now don't confuse that with pq to the power of x, because that's a whole different graph. So we're given some points here. These two especially are important because they will help us find the value of k quite quickly. So we know, for example, that when x is 4, y is 405. When x is 0, y is 5. And then lastly, when x is 2, y equals k. So we have a calculator as well, in case we get into difficulty. So let's have a look what we can do. So let's use this one first. So that would give us 5 equals p times q to the 0. Well, q to the 0 is 1, so that will leave us 5 equals p, which is p is 5. So that leaves us with y equals 5 times q to the x. We definitely know that now. Now we can use this one here, which will give us two values we can put into our new formula, and that should help us find q this time. I wouldn't put these ones in, because then we'd still have, well, if we put x is 2 and y is k, let's just do that, the wrong thing. So if we said y was k and x was 2, we'd still have two unknowns. So I'd personally go with this one. So we can say x is 4, y is 405, so that would give us 405, don't forget we're putting it into this one, equals 5 times q to the 4. So you've got your calculator, so 5's into 405, because we're dividing both sides by 5 first. That should give us, let's have a think, 81. Now if q to the power of 4 is 81, then 81 is 3 times 3 times 3 times 3, so q would be the fourth root of 81, which is just 3. So where does that leave our formula now? Well, we've got y is 5 times 3 to the x. Well, that's a lot easier than what we started with here. So now we can just put x is 2, y equals k, and then we should have the answer, which is 5 times 9, which is 45. So k equals 45. I'm sure some of you have got quicker ways of doing it, but that's the way I would do it if I was doing it in the exam. Question 21. OAB is a triangle, and it says A is the midpoint of OZ, Y is the midpoint of AB, and X is a point on OB. So let's put in the details here. It says O to A is A. And then we've got O to X is 2B. And then X to B is just B. We've got to prove that XYZ is a straight line. Okay, so I'll just put Z here. Now, let's see if we can find X to Y and then separately Y to Z, and then we'll see how they join up, so to speak. So, first thing to look at is, it's not so much the obvious thing here, but it does say that Y is the midpoint of A to B. So how can we do a journey from A to B? Well, we can go from A to O and then from O to B. So A to B, that journey, will be AO plus OB. A lot of you have learnt it as OB minus OA, and that's fine also, but I like to visually see the journey sometimes. Okay, so we'll use this one here. So we know that A to O must be negative A, and O to B is, well, be careful, it's 2B and another B, which is 3B. And we can write that as 3B minus A. Now the important thing is that was A to B. So we know what Y is, it's the midpoint. So surely if I want to do the journey from A to Y, so from here to here, then it's going to be half the journey from A to B. So it's going to be a half of 3B minus A. So we have enough information now to find X to Y. So if I want to go from here to here, I can go from here to here, then from here to here, and then from here to here. It's the same displacement as going from X to Y. So if I follow that, then I'm going to have XO plus OA plus AY. So X to O is the opposite direction of O to X, that's minus 2B, plus OA, which is just A, plus AY, which is what I've just found. I can clear that up a little bit. Now this is a bit messy here, so I'll just rewind that a little bit. When you've got to underline your vectors, you've got to be a bit careful, so I'll write it like that. And then we can neaten this up a bit more, so we can do our A's here. So plus A minus a half is just a half of A. And then we've got 3 over 2B minus 2B. Well, 3 over 2 minus 4 over 2, if you think of it like that, because 4 over 2 is just 2. So we've got 3 halves minus 4 halves is minus 1 half of B. And I can just take a factor of a half out as a scalar. So that'll be, it doesn't have any direction, a scalar, so that'll be that. So that's X to Y. Now, why don't we find Y to Z? And that will show us how X to Z looks, okay? Now y to z, from here to here, I can just go from y to a and then from a to z. Now it does say that a is the midpoint of OZ, so if this was a journey of a, then this is a journey of a as well. So I can put this in because a is halfway. So y to z is going to be y to a plus a to z. Now we know what y to a is, it's minus of ay, so it's minus a half lots of 3b minus a, plus a to z, which is just a. So we can neaten that up a little bit. I'll do the a's first. A half and one more is 3 halves, minus 3 halves of b, and that gives us 3 halves of a minus b. Now here's the really interesting thing. This represents the movement. It's kind of like the gradient, if you must, because a movement of a followed by a movement of b in the order a minus b is just a movement in itself. So that's like the gradient or the direction. And can you notice here that they both have the same gradient? Now if they both have the same gradient, that could mean that x, y and yz are either parallel or on the same line. Okay? And we've got to prove that x, y, z is a straight line. Well, to me that's definitely proven it, because if they've got the same gradient and y is common, don't make it too hard for yourself, just think carefully what I'm about to say, that if x to y had the same gradient as y to z, then they'd have to be on the same straight line. They couldn't be parallel like this in space. Why? Because this point was joined to this point. So you could think of it like this. I want to start here and I end up here. It would have to be crooked. If y was off that line, it would have to have a situation like this, and then the gradient of this would be different from the gradient of this. Or if, for example, you had a starting point here and y was down here and you ended up here at z, well, this would not be parallel to this either, would it? So if I'm going from here to here as a vector a minus b, it's 3 halves. So x to y, is a half of a minus b, and this one is 3 halves of the same gradient. Then it's this common point which is of interest. Now an alternative way was to do xy and then do x to z all the way. And you would have found that also they would have had the same gradient. And because they both started from x and went through y and ended up at z with the same gradient, then it would be impossible for y to be off that line, because again, if it was, then the gradient of x to y would be different than the gradient of x to z. Okay, so this kind of question does cause students a lot of problems, but just try and make your journeys. When I say the word journey, I just mean the movement. So just try and track your movements carefully, and the examiners always give you enough information. So there's plenty of different approaches here. And don't get confused with all your algebra either, because that can let you down severely in these types of problems.